Hello, if you followed the previous tutorial where we were assembling these boundary conditions on our beam model, then you will have a situation like this, and we used our output button to output those constraints to file, ready for our solver, and that means we're all good to go as far as our solver is concerned. It just means that we have to run that. So if I now switch this out of the way, we've got our constraints file. All the files that we need are ready. So the easiest thing to do really is to switch to this directory. So if you actually just click and drag that, it's actually already in this directory, but there we are for that. The solver binaries for Ubuntu hopefully will be in a directory that you have under this release name or something similar, 1404, and the solver that we're hoping to use is this thing called VOX-FE solver. So again, if we click and drag and I switch back to that directory, all we need to do is just to give the solver this file, the script file, and it's able to do the rest. So if I do that, if I beam dot VOX-FE dot script, and that's it basically. If I enter at that point, it will start to run. Now the solver is created with a parallelized version of PETSI, and this is I think it's 250,000 elements, so it will take a little while to run, and therefore it's well worth if you've got the MPI libraries and PETSI installed. If we kill that for now and rerun the whole thing with MPI-N8, my laptop here has 8 processors to throw at this, so we'll send it off, and this should speed it up quite a lot. I've got this is a debug version, so it spits out quite a lot of stuff in there, and including lots of error messages that aren't really errors. So long as it's actually picking up all this data, it's generally fine. But I'm going to actually just pause recording for now. It's going to take a few minutes to run that, and I'll come back when it's actually finished in a few minutes time. Okay, again, the solver finished. Apparently it took 213 seconds or something, which wasn't really all that long for this model. And this is just the tail end of that file, which I happen to know is that theoretically the value should be about -4. In a future tutorial I'll explain that what we do with this displacement file. Basically we can import it back into ParaView. Okay, thanks.